This is the course structure or course contents. First, we will go through this introduction part where we will introduce what is power electronics and what are the power electronic components. And then we will see different types of power conversion methods, AC to DC, that is rectification, and DC to DC, and DC to AC, and AC to AC. So these four different types of converters we are using in power electronics. These are important, and under each category there are so many subcategories or classifications. So we will see quite some details. The course is a bit heavy, so you try to give your focus from the beginning so you will not get lost. Primary goal of the course is you should understand about power electronics and its basics. And we will also see harmonics. What does it mean, harmonics, and how can we do analysis of that, and how can we avoid harmonics? And we will see also some power electronic devices. I will go through some power electronic devices in detail. So, and we will see the converters, different types of converters. And here you can see basic operation of devices. For example, diode, it's an uncontrolled turn on and turn off device. So here we do not have any gate. It's depending on only anode and cathode. By changing the polarity, you can make the device in forward bias or reverse bias. So it does not have really any control to turn on and turn off. Only it's about the polarity. But controlled turn on and turn off devices like BJTs, MOSFETs, GTO, IGBT, and so on. These devices have, you can control in a way by giving some base voltage or base current, or gate voltage or gate current. Similarly, controlled turn on and uncontrolled turn off means you can turn on the device by giving a gate voltage, but you cannot really turn off. It means even though you, after you cut off the gate power supply, once the device is on, the device is going to continuously be in on condition. One of the best example is SCR, silicon controlled rectifier. We will see the detail of SCR later in the lecture. These are three important categories. These devices we are going to use in these circuits. Circuits are converter circuits. So converters, there are four major converters we have in power electronics. That is based on the power source. So maybe sometimes you will have the AC power source, sometimes you will have DC power source, but the load requirement is different. Each load have a different requirement. Maybe some load, for example, maybe your mobile phone, it requires only just, it's depending on the battery, what the mobile phone has. Maybe it will require only plus 5 volt DC, but in our stick contact in our home, the plug point, we have the power supply 230 volt AC. So we need to have some kind of conversion circuit in between our stick contact in the home and then the load, that is your mobile phone or laptop or whatever the application you are going to use. So this converter circuit will convert and control the power flow from the source to the load. We will see the detail now. Power electronics, it's just like a junction of different courses. Actually, we are going to apply the theory from solid state physics, circuit theory, or network theory. You have taken this course in your first year or second year, and we will use some concepts from systems and control theory and signal processing, electronics, especially analog electronics. And we will also use principles from electrical machines, power systems, EMFT, electromagnetic field theory, or electromagnetics, simulation and computing. We are going to use all kind of concepts and principles in this course. I will try to make lecture contents as simple as possible for you to understand. The focus will be on theories and also some practical experiments in the lab. History of power electronics. So it started from actually 1800, 1900. from Thomas Alva Edison. He introduced the bulb. From that time onwards until now, we have so many advanced electronic applications and systems, electrical systems, power generation, transmission, distribution, utilization. So we have so many advancements in the technologies. It's just one simple picture how we are just getting more and more progress in the technology. Year by year, every decade, we are getting more and more advancement. Electronics can help us a lot in terms of varying the output voltage, output current, output frequency, and so on. Load may need different voltage, different current, different frequencies. For example, if you are controlling the speed of the DC motor, so in the olden days, the traditional solution was adding the external resistor. So once you add the external resistor, I will show that circuit in a while, there will be energy loss. Because of the energy loss, the efficiency of the DC motor will also go down. Instead of using this kind of external resistors to control the voltage, so we can just control the EMF of the DC motor. So by controlling the EMF, we can control the speed or RPM of this DC motor. So power electronics was quite important innovation, and that is very helpful in so many different applications. Today's advanced technologies in automobile industry or any kind of manufacturing industry. So we are using that even in domestic applications. We are using these power electronics circuits. These are actually more cost for the government. That is why Tesla was introducing alternate solution actually, but that was until now it was not really used. People are getting to know more about Tesla. Anyway, Tesla is not part of our course, so we don't need to focus on that. So power electronics allows for voltage and current signals to be transformed, and we can use renewable and alternate power sources. For example, windmill, we can use that to generate the power that is kind of sustainable energy, and we can use the solar panels to generate the powers. So in this kind of systems, power systems, we are using the power electronic devices, for example, ACR, thyristors, power diodes, and so on. Without those devices, I'm not sure we can really use these kind of power systems. And also it can integrate the energy storage. It helps to integrate the energy storage. So power electronics is the one single technology that Edison needed in the late 1800s. He did not have at the time. So for example, the MOSFET was really introduced in 70s and 80s, and it got more and more advancements after 1990s, just 30, 40 years ago. Okay, so power electronics is the application of solid state electronics to control and convert the electric power. So here we have to know there are two types. One is microelectronics, another one is power electronics. Microelectronics means it deals with low power applications. Mostly we are handling low voltages and low current. So here what maybe you have studied about digital electronics, analog electronics, even medical electronics, and so on. But in power electronics, we deal with high power systems and high power applications, where the application needs high voltage and high current, especially for power generation, transmission, distribution, and utilization. So we are using these power electronic devices or power electronic circuits. So it relates to the control and flow of electrical energy. So for example, here we have the source and here we have the load. So in between, we need some kind of power processor. So that can just receive this power and it can process the power and it can give the correct voltage and current required by this load. Maybe this load can be any kind of load. Your laptop, for example, this is also a load. Mobile phone, there is also a load. So we have the power supply. So, so it's really depending on, we can put this context in any kind of applications. So this power processor is controlling the, you can see here, it's controlling the flow of electrical energy. So you can vary the current, you can vary the voltage, and you can vary the frequency at the output. So in addition to this power processor, we also need controller circuit or control system. So this control system is really helping this power processor. Let us take one simple example again. So now I have my laptop. I am charging my laptop. My laptop, maybe it needs plus 12 volt DC. So we use this 12 volt as the reference and giving to this control circuit. Or this control circuit will give the detail about the load. So what is the requirement needed in this load? So this information will be shared to this power processor. Then the power processor will process the incoming input voltage and current. Maybe here, for example, I am getting 230 volt AC, single phase, maybe 50 hertz frequency. So now this power processor have a reference. This is called the error signal. So power processor will take this input voltage and it will take the reference signal, and then it will produce the electricity, or it will produce the voltage and current which is required by this load. So this is the simple block diagram that represents the function or the purpose of this power electronics. So we are using power electronic devices to build the power electronic circuits. Power electronic circuits are used in this power processor. Now, of course, we have the control systems as well. So then you should just remember, power electronics is acting as an interface between the source and the load. So this interfacing is very important in order to maintain the efficiency as well. So one simple example, as I already mentioned, our mobile phone charger. So we give the input as a 230 volt 50 hertz AC. That is, we are getting from our power outlet, the stick contact, and output, our phone requires only plus 5 volt. So we have the small phone charger, right, adapter. So it has the power electronic devices inside, and it will convert this AC into this plus 5 volt DC. So we, inside the mobile phone, for example, we have this lithium ion battery. It has the capacity of 4.2 volt. So this is one just a simple example where we are using this power electronics. Of course, what is the magic behind? Which one is converting this 230 volt into 230 volt AC into 5 volt DC? There is no magic actually. So that is the power electronics.